So I want to talk about a few relatively new features in Java and how we can make use of those for designing software and how we benefit from them. So first of all, this is about the three amigos. Well, why three amigos? The reason it's three amigos and not three features is not just that we have these three features, but the way these three features play together. And so the interplay of these features, what really creates this nice friendship of these features together. And so the features we're going to talk about here today in isolation are the features of pattern matching, records, and sealed classes. But we're also going to see how each one of them come together with the others to provide a nice capability as well. And then we'll just touch on this a little bit towards the end and talk about how this contributes to what's called the data-oriented programming. So let's get started with the first one, records. So let's talk about records a little bit. So let's start with just a little example of, let's say we want to create a little class, and let's say this is a class called person I want to create. So we all have done this, right? So you have a class called person. So you want a field within this particular class. So we say in this case it's private, and let's call this one as a private. We'll call this as first name. So it's a string. So we'll say string first name. Let's create it. We'll create another string, which we'll call this as last name as well. But then are we done? Oh no, you have to write a constructor for this, right? So we say string first name, and then we create a string, which is a last name as well. Then you say this dot first name is equal to the first name, obviously, and this dot last name equal to last name. Are we done? Oh no, you have to write a getter, isn't it? So where you say get first name, and in this case you have to say return the first name from this particular object. And likewise you would say get last name right here. And of course in this case you're going to return from this the last name as well. And now if you were to go back and say output new person, and let's just simply say this is going to be Alan and Turing as the person, so we could write code like this. But you look at the amount of effort you had to take to write this. That's quite a bit of code to write, isn't it? And you're saying, oh no, Venkat, that's not true at all, you protest, right? And you say, I don't write that code. I just merely write this field. And then I gently right-click on it. And before I can blink my eyes, my IDE vomits the rest of the code. Now you have to live with that vomit forever, right? So the question is, why do we have to create all that code? And especially, there are two kinds of classes we often work with. Some classes, maybe a lot of classes, that you write represent abstraction. So they represent a certain concept in your domain. You typically write the classes to implement methods that have certain behavior and logic and properties and such. But there are times you create classes whose job is to simply carry data around. You may make a request to a remote web service, pull a data from a service. Now you create this object, but it's really a data holder. So in other languages like Kotlin and Scala and a few other languages, they may call this with other names. For example, data classes or case classes and so on. But as the name alludes to, a data class is useful just to keep the data around. This is not something that models behavior in your code. So the question is, and in fact, after all this effort, right, of writing all this code, when you run it, it gave you a pretty useless information. How sad that is, right? So for putting all that effort, you still got information that's of no use to us. So the question is, how can we write less code to achieve better results? This is where we have what are called records. So you go back to this code and you put a parenthesis like so, turn the class into a record, and you say, here comes my first name, and here comes my last name, and I am done, and I don't need to write anything more. So we can remove all that boilerplated code, but when you run the code, you even got a more useful information when you ran this code. So that is basically a record where a person contains a first name and a last name. I like to say they have properties of first name and last name. They call them components. So it's got a first name component and a last name component. But that's what you got so far. But let's go a little further beyond this. Raise your hand if you like to get free stuff. Anyone who likes free stuff? Yeah, we do, right? How do you like buy one, get one free offer? We go for it, right? But this is better because this is Java. You're not going to get a buy one, get one free. How about buy one, get 5 free offer? Anybody for that? Yeah, that's what I'm talking about, right? So buy one, get one free. What is it? You bought a record for which you didn't actually pay. That's okay. But for this, you can get 5 things free. So what are the 5 things you're going to get free for that? So the first things that you're going to get for writing it is the very first thing, you get a constructor for free. That's cool, right? So you wrote a record and you automatically got a constructor. That's your first thing free. But Java says, we're not going to stop there, right? Buy one, get one free is not good enough for us. So here's the second thing you're going to get for this. You're going to get a getter for each of the properties. So you got a getter for the first name and a getter for the last name. That's a second thing you got for free. The third one you got for free is the toString method. That's why you notice when you printed it gave you something more useful. You can override it if you want to, but that's given to you already. Then you have an equals method and you have a hash code method as well. So all the 4 of those are provided for you automatically. So when you write a record, by just defining it, you got all those 5 things given to you. But when it comes to a record, there are a few things you need to really be comfortable with. The first thing is that records have, well, let's put it this way. The first thing you need to keep in mind is records are classes with a few very good limitations. So records are classes, but those are classes with a few limitations or restrictions. The first thing is records are immutable. So you are not allowed to modify the components like first name. So you cannot change the components like first name. They are immutable. So if I go back here and if I say person is equal to new person, so we got a reference to the person, and if I say person right there, you can see we printed the person. But I say output person dot first name. So that's your getter that you have access to. And you can see it's Alan. But what if I say person dot first name is equal to Alan? Well, that's an error. You are not allowed to modify the first name. You cannot do this also. Set first name. You are thinking, aha, I can call a set first name function in here. The answer to that question is, no, you cannot do that either. There is no such method. Hey, what if I simply said first name and call it like this without really using the word set? You cannot call it like as a function. So in other words, you cannot modify the first name. Once you create the object, it's immutable. So that is the first thing about records is these are immutable. The second thing is you can say records are, you can say final classes. So you cannot inherit from a record. By nature, they're already final. You cannot extend from it. And records are not allowed to have a base class. They already extend from a record class. So essentially, that is java.lang.record. So that's another restriction. So you cannot give a parent for a record. You cannot give a child for a record. Those are final, and they already extend record, so you cannot add another parent other than record, which already exists. So those are some of the restrictions, and we can go a little bit more further into it. Records are not allowed to have a base class, but records can implement interfaces. So you can tell the record, implement this interface, that's perfectly allowed. And a record typically has what's called a canonical constructor. But a canonical constructor, you may call it as a default constructor, right? So it's a canonical constructor. In this case, the canonical constructor is implemented automatically. What if I want to do something special? The general recommendation is don't implement a canonical constructor. Instead, implement what's called a compact constructor. The compact constructor is much more concise and removes the reason to redundantly initialize properties that you don't have to really change. So that's why it's a compact constructor. That's a recommended practice in terms of how you write those constructors as well. So with that said, we talked about records. And if you have any questions or comments, there you go. That's awesome. So if you have any questions or comments, ask the question right away. Somebody was saying yesterday, oh my gosh, you did not ask me for any questions in the end. Why wait till the end when you can ask questions right now, please? There you go. You know why? So the question is, hey, I cannot extend a car from a vehicle. Instead, they're saying use composition. Why? Well, remember all those books we read and nodded our head. What do the books tell us? Good books tell us it's better to use composition than inheritance, right? So finally, they are saying, let's do that. So inheritance is a very poor choice a lot of times. And object composition is much better. Why? Because a data class is oriented towards data. Well, when you have data, when does inheritance maybe make sense? When you want to override a behavior. Well, there's not a whole lot to override here because all you have is data. There's no behavior to override. So that's why inheritance doesn't make any sense. That's why I love these kinds of questions, right? It allows us to think about this a little deeper and ask the question, why did they choose to do it this way? Because there's nothing to override. You compose data, but you override behavior. And there's not much behavior here to override. Then write a class, don't write a record. Yep, that's what classes are for. And guess what? We've had it for a good 30 years now in Java. And even further for OOP, about 50 years now. So we can continue to use that. So records are not a replacement for classes, right? Records are replacement for data classes. Because you wrote those anemic classes that didn't have any behavior and only had data, but you don't have to write a boilerplated code. That's the purpose for it. So, yeah, please.
Records also take care of it if they have they go after.
Yeah, so good question. This is your responsibility to make sure that the records are immutable. So the fields are immutable, meaning references are immutable. So the rule you want to follow is create a record with primitives because we know primitives are immutable, right? Create a record with such things like string because they are immutable. Do not create a record with the string builder, right? Because string builders are mutable. So a good idea is create records with primitives, things like string, which are immutable objects themselves, and other records created in the right way. So that's generally your practice. The documentation says if you violate that and you allow for record to be mutated, the behavior is undefined. There you go. So the answer is don't do it. It's your responsibility, right? The language is not going to protect you from doing it. That's for us to do. Yep.
It takes the 3 video to the might have a year that is the sorry, We are not able to.
Oh, you can. The intention is not to put behavior doesn't mean you're not allowed to put methods. There's like, English is a very confusing language. You got to read closely. The intention is not to pack behavior. So if you say, I'm going to put 20 methods in there, rethink what you're doing. But you're saying, yeah, but age is something that it's a convenience method. It's not quite a behavior, right? It's a data transformer. Yeah, go for it. Nothing stops you from doing it. Absolutely. In fact, that's one of the reasons. Think about it this way. When I say you can implement an interface, if you implement an interface, you got to implement the method in the interface, right? Otherwise, what's the point? Unless it's a what do you call those interface with no methods? Marker interface. Thank you. Appreciate that help. Marker interfaces, right? But this is not, you can implement any interface you want. That's exactly right. Awesome. Cool. So now let's switch gears. Let's talk about sealed classes. Well, they call it sealed classes. However, those can also be sealed interfaces. I'm going to quiz these people questions in a few minutes. You need to answer my questions, right? The lady over here. Hello, madam, look at me. So, you want to talk? Outside you can talk, or you should talk to me. You can talk to yourself. Look at these people. They're not talking on themselves. They're talking to me. So you can talk to me also. You want to talk to yourselves? Outside. This is something we need to learn. When you're in a public space, you need to learn how to behave in a public space, right? That's called being professional. You got to keep that in mind. So essentially, when you are dealing with the sealed class, it's also known as a sealed interface. So a sealed class or a sealed interface, what is the main idea behind this? Well, you want to create a hierarchy of classes. But let's entertain a little concept, a little thought. When I create a hierarchy of classes, I don't want anyone to extend from my class. We know exactly how to do it. How's that? That's right. To mark it as final. If I make my class final, no one can inherit from it. That's awesome. Well, if I want no one to inherit from my class, but wait a minute. I want my folks to inherit from my class, but I don't want third-party people to inherit from my class. So I want to kind of define a privilege. My system can keep extending, but others can use it, but they shouldn't extend from it, right? So now we want a final in the eyes of others, non-final in the eyes of my members, right? Why would you want to do something like that? Well, the reason is there are times when you create abstractions where the abstractions are for others to use, but not to extend it further. I am defining a deck of cards. Take an example. Well, my deck of cards has 4 different types, right? The spade, the diamonds, the other 2. Now, I want you to use deck of cards. And suddenly, as I'm looking at it, there's a 5th type in there. I'm like, darn it, how did we get the 5th type? And you're like, we decided to cook our own, types in here. Whoa, no, you're not allowed to do it. You are allowed to use the cards, but you cannot cook up your own little, symbols, right? So how do you define such a behavior where a hierarchy can be defined by you, others can use it, but they cannot extend it? Well, you could say, you know what? If you really, really want to do it, create a abstract base class called card, create your spade and the diamonds and so on, and now make those final, and nobody can extend from it. I get it. But what about the card base class? Ooh, I got an idea. Make the card base class package friendly. Well, if you make it package friendly, others cannot see it, so they cannot extend it, but they can see your spade and the diamond and so on. That's great. Oh, that's nice so far, but that means you are limited from them seeing this top-level abstraction, so they cannot use the generalization. And the second problem is, what if the card was an interface? Anybody else who's heard about final interface? Anybody? No, that person is not in the room, right? Yeah, So it doesn't make sense to make an interface final, because if you make an interface final, nobody can inherit from it, right? What good is a final interface? That's an oxymoron, right? That doesn't make any sense. So the question is, how can I define an interface so that others can use it but cannot extend from it? That is the question we are asking right here. So the answer to that question in here is, how do we get to the point where we can create an interface, we can tell that they can use that interface, but they better not go around and start extending from that interface. That's what we want to do here. That's the concept of sealed, and you're kind of sealing this and saying, that's it, this hierarchy is closed, you can use it as it is, you cannot extend it anymore. So let's take a look at an example of how we can actually do this. So what I'm going to do here in this example is, we'll come back to this in a few minutes, I'm going to go back and say a trade.java. And what am I going to do with the trade.java? Public class trade, public interface trade. By the way, it can be classes or it can be interfaces. They call it sealed class. If you make a mistake, even if you write an interface, the error message will say sealed class. But generally the term is a sealed class, but it's a class or an interface, doesn't matter. In this case, we wrote an interface called a trade, and I'm going to say it's a sealed interface. So to the sealed interface, I'm going to say this permits a buy and a sell, right? So we are saying a sealed interface is permitting only two children, a buy child and a sell child, right? So this is how you create a closed hierarchy. There's a shortcut notation, but there's no point in talking about it because that's also not that useful. So this is generally how you would define a sealed interface or a sealed class. Whether it's a class or an interface, doesn't matter. So now that you defined a sealed interface called trade, and it permits a buy and permits a sell. So then I say, in this case, buy.java, and the buy.java says a final class buy implements, in this case, trade. And then within this, I say private string ticker and a private, let's say, int quantity. And then I'm going to say public, let's say buy, and let's say this is a string ticker, and let's say this is an int quantity. Let's bring those in here. And then I'm going to say, obviously, in this particular case, I'm going to say this dot ticker is equal to, let's go ahead and tie that in, ticker is equal to ticker, and this dot quantity, let's say, is equal to the quantity as well. And you know kind of where I'm going with this, right? Public string, you could say get ticker, that's going to return the ticker as well. And then you're going to say in this particular case, similarly, I'm going to have a int, and let this be get quantity, and this is going to return the quantity as well. So let's start with this for a minute. Then I'm going to say a cell.java. So what does a cell.java actually do? It also implements from the trade, but this is a sell rather than being a buy, and that's basically what you have so far. So now that we wrote all of that, let's go back here and say output new buy, and I'm going to say, let's go ahead and say this is AMZN, and let's go ahead and provide 1,000, and let's go fire it up and see what it does. It worked. However, I am going to say a final class, and I'll call this as my trade, implements trade. So I'm implementing the trade interface. So when I implement the trade interface, I wrote a my trade in this particular case. But guess what? I am not part of that group of classes, isn't it? Trade permits a buy and a sell, but it doesn't permit a my trade. So when I run this code, I try to run a code, it gives me a compilation error. what does the error say? Error, class is not allowed to extend sealed interface trade. And why not? Because it's not listed in the permits clause. So it says, hey, they didn't permit you to be a member of this hierarchy, so you cannot just go around using it. You can use the trade, but you cannot extend from it. So that becomes an error, and so you cannot do that. But you can do the following, right? You can say trade is equal to new by, and then you can output the trade like so. That's perfectly fine. You can use trade, but you cannot implement trade. So far, so good. So we talked about the reason to write it, and we talked about how to write it as well. However, there are a few small details I want to mention. I won't go into too much detail here, but I want to mention this. And the first thing is, notice this code compiled with no errors, right? That seems to be fine. But if I go back to buy.java and I remove the word final, if I remove the word final, notice I got an error. It says sealed, non-sealed, or final modifier expected. So it tells me if you are going to implement or extend from a sealed interface or a sealed class, then your class is required to be final, or it's required to be sealed. Now let's take a look at this for a minute. It says it has to be final. Does that make sense that it has to be final? Yes or no? Yes. Why? Because I want this to be the leaf, and I don't want you to extend from it. So that way the sealed hierarchy is protected. So this is saying sealed, this is a child, and you're not sneaking around and extending from the child. So that is sealed. Final is the one that makes the most sense, isn't it? But you say, hang on a second, I've got a parent, I've got a child which is sealed, which is final, but the second child is going to be a parent for one more level below. I want my hierarchy not to be one level, but I want my hierarchy to be 2 levels deep. So if I mark my first level as a final, I cannot have a second level. But if I don't mark it at all, it's free for all. I cannot stop others from just going over and inheriting from it. So you're saying this is sealed, this is final, but this one is also sealed, which means I will tell what I permit in the next level. So sealed, permit buy and sell. Sealed, buy. And this is whatever permits child 1, child 2, child 3. Sealed makes sense? So far, if you tell me, Venkat, this makes sense, please stop talking. I want to go home now. You are allowed to say it. Nobody said it. Had you said it, you would have slept well tonight. But you chose not to. And you asked for it. Then there is non-sealed. What does non-sealed say? Non-sealed says, remember how we closed this. Remember how you cannot inherit from this. Remember how we tell what can inherit from it. Forget all of that. This is free for all again. And you look at this and say, okay, now I lost you. Why would you build all this beautiful thing and then say, you can do whatever you want to do? This is like building a beautiful boat and then telling somebody, here you go, you can use that to drill a hole in the bottom. Because it completely jeopardizes the whole thing, isn't it? Because the minute you have a non-sealed, you can create anything you want.
That's it.
So you think about this and say, were they drunk by giving this feature? And I think you know the answer, right? No, don't say definitely. No, that's not what I meant. You know the answer. They are some of the smartest people in the world. So the question is, why did they do that? And the answer to that question is twofold. One, there are times when, I know a lot of people don't do this, but some people, rare people, do this thing called testing. And you say, I want to test this code that depends on this interface. And when you want to test a code that has a dependency, what do we normally do? Thank you. I was worried now. You said mocking. I thought you were going to say give it to somebody else. Okay, mocking. Well, how do typically mocks work? Mocks typically are classes that extend another class or implement an interface. But my interface is sealed. And the mock says, hello, I want to inherit from you. And the seal says, you cannot, you're not allowed to. See, we got a little problem, right? So you need to say, it's all sealed, but I want to open this up to mocks. Use case 1. Use case 2. You're working in the system. You have a sealed hierarchy. Everything is going well. And third party cannot extend from it. They can only use it. Everything's going great. Until these two members of our team come to you, the architect, and say, hey, architect, I want to create a brand new class for experimentation. This is not production ready. We may not even send this to production. But I just want to create an experimental class and play with it. Okay, what class you want? I want this class, here's the name. Okay, permits that experimental class. And they go play with it. And they come back and say, we don't need that anymore. Okay, remove the permits. 2 days later, we need these two again. And the programmer whose job is to maintain that class is going to be happy? No. And the poor guy looks at his Git commit. You added it, removed it, right? Does that feel right? Or does it feel smelly? Yeah, that's very smelly, right? You kind of look at this and say, I don't know what's wrong, but I can tell you this is wrong. I have that feeling sometimes, right? So you're like, there's got to be a better way to do this. So now you get the picture, right? So what am I going to do? I got to seal the trade. I got to buy, which is final. I got to sell, which is final, or seal, doesn't matter. And then I have an experimental trade. Making sense? My experimental trade is marked as what? Non-sealed. So you say, hey, I like testing. Can I create a mock? Go for it. You create a mock from experimental trade. Okay, maybe you will call it as, mock the test trade. Whatever you call it. What about these two dudes here? They create their experimental class to inherit from experimental trade. Whom do they have to go talk to be able to inherit from that?
Yeah.
What was that?
Very good.
Yeah, but whom should they have to talk to inherit from that? Nobody, because it's non-sealed, right? So far, so good. This is where I ask you, we found 2 use cases, but there's something still that bothers me. And what is it? They can inherit from experimental, but what stops? Yeah, everybody else to inherit from it, right? Jayashree is like happy. I found the loophole in this. I'm going to have 3 classes inherit from it. Well, no, I don't want her to extend it. I want her to use the hierarchy, not extend it. So it's not my inner team to extend it. So this is my recommendation. My recommendation is if you choose to implement non-sealed, make your non-sealed as non-public. Make it your package private. If I make it package private, what happens? My team belongs to the same package. They can inherit from experimental trade all they want, and they can keep destroying it, and recreate other classes, but a third party does not see my experimental trade. So my recommendation is don't make non-final a public class. Don't make non-sealed a public class. That doesn't make any sense to me. So this is where we have to understand, when you look at a feature, the minute you see it, you're like, duh, that doesn't make any sense. So then the question is, let's reason. Why would they have done it? And how do we tame that beast? How do we make good use of it in a way it gives us the benefit, but not the drawbacks that may come with it? So that becomes more tamed and manageable use of that feature. So we talked about two things here. We talked about the records. We talked about the sealed. That takes us to the next one, which is pattern matching. Now, we used to have, we still do, a concept of switch statements. A switch statement receives a particular data, goes through case, and does things for different types, values of data. You know, in the case of a switch, you better put a break. If you don't put a break, it has the automatic flow to the next one. So if you don't put a break, you added a bug in the code most likely. So it's more error prone. That's one problem. The second thing about switch, what is one difference between a statement and an expression, if you will? What comes to your mind? What is it that a statement will do, something smelly, that an expression would not do? What's the fundamental difference between statements and expressions? That's right. Statements mutate state. If you say, my statement never changes anything, right? What statement will never change anything? A statement that doesn't change anything at all. What is that statement called? Comments are evil. What was that? No, the constant is not a statement. It's called a no-op. It's a no-op. What does it do? Well, it doesn't update, but even more, what does it do? Nothing. It's a no-op. What good is a statement that does nothing? That's like some employees in the company, right? What do they do? Nobody knows. Nothing. Sometimes they don't even show up to work these days. So the point is, it's a no-op. That's useless. So any statement that does anything useful will have to mutate state. But more the mutation is, the harder it's to reason about the code, more error-prone it is. So the general recommendation is, prefer expressions over statements as much as you can. Well, the beauty is, in Java, statements have morphed themselves into expressions when it comes to switch. So you can write a switch either as a statement, or you can write a switch as an expression, either one of those. Not only can you write this as an expression, you can use that now for this beautiful pattern matching syntax. So the question is, what does it mean by beautiful pattern matching syntax? And the idea behind that is, if you want to perform a series of operations depending on not just the value in a variable, but maybe even the type of that variable, then you can start writing them into a pattern matching syntax. So let's take an example here. So what I'm going to do here is to say process, let's go ahead and say in here, output process, and what am I saying? New by, let's say AMZN, and let's say a 500. So I have a buy, and I have a sell. Let's sell some MSFT. Let's sell 200 quantity of that. So what is the process going to do? So I say public, in this case, a string process. And I'm going to say, here comes a trade that comes in as an argument. Then I say return, switch, and trade. Let's start with that one. Notice how you're able to put a return after a switch. That tells you that a switch is an expression in this case, because you cannot return statements, right? Because statements don't return values to you. So what are we going to do here? Case, and this is a buy, and I'm going to simply say we are buying, and what are we buying? A percent S, a D, stocks of percent S dot formatted. So formatted, this is going to be the quantity buy dot get quantity, and then comma buy dot get ticker, and I'm going to buy that. Likewise, you can say sell, and this is going to be a sell. We are selling that quantity, and this becomes a sell dot get quantity, sell dot get ticker. But default, what are we going to say? Invalid or unsupported trade. So we're going to give an error for that one. So we're buying 500 stocks of AMZN, selling 200 of MSFT. What if it's neither one of them? Then it's going to be a invalid or unsupported trade. So far, so good? So in this case, we are pattern matching based on the type, which is the buy, and we are doing some action based on those for those two types. So if we stop right here, we could continue to understand the different types of things you can pass to a pattern matching syntax. You can say, ooh, this is a pattern matching, and we can have values, we can have variables. So there are so many different combinations of things you can pass to it. But there's a little bit more to it. You can say, we have a buy, we have a sell, but this sell is for Goog. And this dude is selling 20,000 quantity. And the big brother, you know whom I'm talking about, right? Tells your financial company, if the trade is for small values, don't worry about it. But if the trade is a big value, we need to audit it. We need to notify. We need to look into it further, right? So this is the big brother rule. And so what are we going to do here? This is called a guarded pattern matching. So you're putting a guard on it. So what are we going to do for the sell? We go back to the sell and we say sell when sell.get quantity is greater than 5,000. We are selling big. This is going to require some auditing, and we'll audit the sale, right, for that many stocks. We are selling big, and we'll audit, spell it properly, audit, okay, that didn't help. Try this again. So audit for the sale of 20,000 stocks of Google. So this is called a guarded case. You're saying if a condition is met, go this route. If the condition is not met, keep going further. Now, so we looked at the guarded. Now, we are humans. Okay, most of us are humans. And when we are writing this code, it's possible we do that, isn't it? Okay, it's taking a photo. So let's say don't do this. Okay, now take the photo, please. Otherwise, people take a photo, they put it on social media, and somebody says, this guy's an idiot. So now go for it, right? So what happens in this case? So this one, we said sell, And then we are saying sell get quantity. Is it possible we make a mistake like this? Right? I will not name the language here. But there are some languages. When you write code like this, they will not tell you anything. They won't give you an error. The code will misbehave if you test it. That's why we don't do testing. But they won't tell you that you're wrong. But if you turn up the volume on your computer, when you compile this code, you will hear it laugh and say, look at this, right? That's kind of evil, isn't it? But Java is a friendly language. It loves you. It cares about you. So Java has this concept called dominance. And Java says, wait a second, that's not valid. Why? Error. This case label is dominated by a preceding case label. It says you will not get here at all because the top one is going to hijack all the available options for that cell. So this is silly code. Don't write it. Within reason, Java implements this concept of dominance. So as a result, that let's put it back and it's happy. So it'll make sure that things are in the proper order where it can, right? If you write really twisted code and you say, oh, look, it doesn't find, hey, it tried. So within reason, it'll be able to help you with it. So we talked about dominance. We talked about guards. So far, so good. But yes, please, fire away. That's why I said within reason. Don't be unreasonable.
Okay.
Yeah, I mean, it does what it can, but beyond further reason, it cannot go into analyze that, right? So within reason, it tries that. That's why you can immediately push this to say, look, it doesn't do this. Yeah, within reason, it does that. So where it's meaningful, it can do that. Or where it doesn't have to spend, keep in mind, everything is a trade-off. Now we are saying, look, your compilation is taking 7 seconds to compile. And now you complain that the compiler is slow. Is there any language where compiler is slow? We don't name such languages. Good. All right. And there is. That's the whole point. That's a compromise, right? So that's why within reason. They don't want to go overboard with it. It's not that they don't have the ability to analyze it, but such analysis brings more complexity. One of the things we often don't realize, right? You may say, I want this small change, which is good. You have the right to say it. I have the right to say it. But a small change I want could be very costly for a compiler to make. They may increase the complexity of the compiler. They may increase the runtime performance of the compiler. So it may not be worth it. Even though I may complain, say, ooh, I wish this language has provided it. I'm the armchair programmer, right? I can sit here in my armchair. Oh, if only you provided this. And then people like Brian Getz are like shaking their head. It's like, nah, this is not going to work because it's too expensive for us to provide, right? And it doesn't cover all the other complications that may arise. That's why it's within reason. I'm very sympathetic to that for that reason. Now let's switch gears a little bit. We saw these kind of things in isolation. Now let's take a look at the interplay of these different things. Let's go to the interplay. The first thing I'm going to do here is, notice we have this default and all these things, right? So far, so good. But I go to my trade, and in the trade, we have a sealed interface called a trade. This is sealed already. Because it is sealed, guess what? I'm going to go and remove the default. And notice it didn't complain. Why did it not complain? Because we covered all possible values, didn't we? If I go back here, I don't have the by, and I get an error. What's the problem? Expression does not cover all possible input values. But because I had buy and sell, that covers all possibilities. Why? Because trade can have only 2 children. buy and sell in this example. So you don't have to write a default, right? So yay, I didn't have to write a default. Question. I didn't have to write a default. Should I write a default still? A little louder, please. We won't get any error, right? Not the third case as in this case, the second case you mean, right? The third, you remove this one, you will have a problem, right? Because that's not complete. Because you can have still cell that doesn't have that quantity. So that should fail as well. But if you remove the second one, that should still pass. So if you don't write a default, you're good, as long as all cases are covered. But the question to you is, the compiler doesn't care, but should I still write default? Yes, absolutely. Why? Because I get paid by the number of lines of code I write, right? I can invoice another $1,000. This is for default. That's a good reason, right? That's how you keep economy moving. Something tells us that's not a good reason. Let's come up with another reason. Why should I implement it? What was that? Non-sealed? Oh, forget non-sealed for the minute, right? Because that's hidden away. I cannot see it from the outside. So I cannot create an instance of it. But the compiler didn't complain. That's a key. The compiler didn't complain. Should I write a default?
Yeah.
Why?
What if trade is null?
What if trade is null? Then handle the damn null. Don't write a default, right? So, should I write a default? Bingo. Tomorrow, somebody adds the class that implements trade, which is also in permits. 2 scenarios. Can we agree? 2 scenarios. Scenario 1. After that has been added, somebody recompiles this code. What's going to happen? Compilation error. Did we need the default? No. Because if you put the default, the code would have compiled. What's wrong with that? You wrote code for the future without knowing what the future is. What's that called? Dumb idea. Yagni. I love it. Thank you. Thank you, ma'am. Yagni. It's Yagni. Premature optimization. Coding without knowing what you're doing. And you get no compilation error because there's a default. And somebody comes to you and reports a bug. And what does the bug say? We added a new type, and this code is doing stupid things rather than doing the right things. So would you rather have a compilation error, or would you rather have the code do something wild that nobody really spent time thinking? Compilation error, right? That's scenario 1. Scenario 2. This group maintains the trade hierarchy. Fair enough. That group is creating objects of buy and sell. And they are calling the code written in the middle. And the switch is right here. And you didn't put the default. Because why? When you compile the code, you handle the buy and sell, no compilation. Right? They added a new trade and provided as permits. Obviously, they compiled the code. And they gave the compiled binary to this team. What did this team do? This team said, boom, create an object of this new type. They're allowed to do that, right? And obviously, they recompiled the code. But guess what they didn't do? Recompile the middle part. Why? Hey, that's a third party. And I have the binary with me. I never thought of recompiling it. Fair enough? So now they call the method at runtime. What's going to happen is the question, right? That's a genuine question. Had you written a default, it would have handled it. But you didn't write one. But here's the beauty. If you don't write one, they write one for you. It's kind of like if you've watched TV shows or if you've ever been arrested, what do they do to you? Okay, not exactly. That's not a good question. What do they tell you? They read out what's called the Miranda rights. If you don't have an attorney, one will be provided for you. If you don't have a default, one will be provided for you. So this follows the Miranda rights. So if you don't write a default, one is given for you. And guess what that will do? Well, why guess? Let's find out. So you can go back here and look at the code. So I say Java C minus d bin star dot Java and Java P. Let's go to bin sample dot class. Let's take a look at the binary it created. And what do we notice in the binary? You will notice in the binary, look at that beautiful thing. Default match exception. If you don't write a default, one is given for you. Isn't that cool? So you don't have to write one. In the small weird case, when the middle part was not compiled, it'll give you that error. But in 99.9% of the case, you compile the code, you got a compilation error. Moral of the story, don't write the default if it's not needed and still invoice the client for what you didn't write, right? So the point really is, just kidding. So essentially the idea behind this is you can use that. So that takes us to two more things I want to quickly show you. And that is, we saw the benefit of the sealed. Let's go back to by, and I say, rather than final class, I say record. You know something about a record already, right? They are final classes already. See how that nicely fits in? They're final classes. Implements trade, but this is a string ticker and an int quantity, right? You brought that in, and now that you are by. And likewise, you are by to the cell, edit the cell, and in the cell, I'm going to turn this into a cell. That's your record for cell. Go back to, go back to sample now, one more time, run the code. Hey, what's going on here? It's no longer get quantity, right? It's actually called as quantity with a lowercase. And similarly, this is a quantity with a lowercase. There's no more get ticker. It's a get ticker with a lowercase like so. And similarly, this is a ticker right there as well. So then you have those coming in here. So let's change that too. So that's basically, okay. So cannot find the symbol get quantity. Still there's something lingering. So this is the quantity, right? So that's the quantity and that's a quantity. Thank you. So we have those values coming in nicely. Great. Now that's a record. You say, okay, Venkat, did you gain anything? Not yet. But notice what I'm going to do. I want the quantity and the ticker, right? This is called destructuring. Destructuring is the opposite of structuring or construction. So I can say by right there and string ticker, comma, int q. And I can change this to formatted. This simply becomes, instead of quantity, by dot quantity, I simply say q right there. Let me move this to the next line so it's a little easier for you to see. So then this becomes just a ticker because you extracted it out. So the ticker is a local variable that deconstructed, pulled the value for you. Similarly, cell, in this case, string or var, tkr, var q, and when q is greater than 5,000, then you can say we are selling big, audit, formatted, that becomes a q right there, and this becomes a tkr. So essentially, you can see how you can deconstruct that and bring that in. So a string thicker, it wants a semicolon somewhere. We'll find out where that is. There we go. So then, what about this guy? This you can change it to a var t, a var q, and you can simply say this quantity is q now. And similarly, you can say these can change. This is going to be q and t. So essentially, you can deconstruct it as well. And please don't give ridiculous variable names like this, but you can give nice names for these variables, right? So essentially, with the records, you can deconstruct as well. And that's how you can see in this example the interplay of all those three things together. So what are we doing here? Rather than using OOP, we are leveraging pattern matching to treat this as data. So I'll summarize this with one observation that might help you to think about this a little bit more. And that is, see if this makes sense. In OOP, we use polymorphism. In DOP, we use pattern matching. So essentially, we rely on polymorphism in the case of object-oriented programming. We rely on pattern matching in data-oriented programming, because the focus here is not on abstraction of behavior. The focus here is processing of data. So you rely on data processing, and so it works really nicely to be able to do that. I hope that was useful. That's all I have. Thank you.